Okay, hi everyone. Welcome to the last webinar of today, and we are going to be talking about current missions in space right now. I have been preparing for this for several days now. I'm really excited to talk about this. For those of you who are watching the last webinar that ended just a few minutes ago, for subtractions, how to multiply and divide fractions, that's going to be really important if you're looking for if you're thinking about any kind of career in space exploration, space technology, anything like that. Math is going to be really, really, really important. We're going to talk about exactly what could go wrong if you do math wrong in a little bit. And for those of you that were watching, yes, I did eat my cake. It was delicious. And it was definitely worth doing the fractions, doing the math in order to find out how much cake I get to eat. Okay, it's just me for this one. Diego's not here. I had to launch him to the International Space Station to handle some things really quick. Actually, he's busy teaching a class, but I'm afraid he couldn't join me for this one. He will be on, I think it's tomorrow. Yeah, tomorrow morning, we're doing space activities. And then the next morning as well, Thursday morning. Okay, I have a lot to get through. Let us get into it here because we're definitely going to run out of time. What space missions are happening right now? First, let's look at who is operating in space. What countries are operating in space? It's really expensive to go to space, to send people to space. It's really expensive and it's really dangerous. People have died in the history of space exploration. It's a little rough to talk about that, but it's a fact. And you do anything new that has danger to it, and there's a chance to get hurt. So it's mostly governments that have taken on this challenge. They're willing to invest the time and the money and take on the risk of exploring. And ultimately, it is very, very, very much worth it. I'm extremely grateful for those who have come before in space exploration, the brave men and women who have strapped themselves into chairs on top of rockets, which are basically big controlled bombs, and sent themselves up into a place with no air where everything is designed to kill them. And they do it all the time. I'm very grateful. So we have the United States. They operate NASA. We're probably all familiar with NASA. Europe, the European Union, different countries of Europe have come together and formed the European Space Agency, the ESA. Soviet Union. So for a long time, space was the United States versus the Soviet Union. And after the Soviet Union collapsed in 1989, 1990, and became modern day Russia, here's that arrow, goes from Soviet Union to Russia. Their really impressive space program reformed into a group called Roscosmos, and that is the Russian space program. So when it's Roscosmos doing a mission, I'll have this logo on here. If it was the Soviet Union before Roscosmos, I'm going to have the Soviet Union flag up there, so we give correct credit to the men and women that did the work. Some more recent additions to the game here. We have China has been doing a lot in space recently, and it's called the CNSA, Chinese National Space Administration. I think that's what that stands for. Japan has JAXA, the Japanese Aeronautic Exploration Administration. And India just recently has been getting into this game of space exploration. And their group is called the ISRO, the Indian Space Research Organization. I'm super excited about India joining this game because it is a competition. It's a game, and a game is better when there's more players that are all really good playing against each other and sometimes cooperating together. There's a lot of missions where several of these groups cooperate and pool their resources in order to achieve a common goal, which is kind of the best of humanity, right? Okay. I am going to get to the Q&A section as much as I can here. I'm going to make a prediction right now. I'm going to predict that we are going to go past our 3:15 cutoff time today. And if you want to stay later, stay with me. I'm going to keep going until I get through all my slides, even if it's after 3:15 when we're supposed to end. Okay. All right. So someone asked, what does NASA stand for? Better define that. National Aeronautics and Space Administration. National, having to do with the nation. Aeronautics, having to do with the study, travel, and exploration of air, space. Okay, space. It's up there. Administration, the part of the government that is that has a certain job to do, and that administration is space exploration. Okay, we are going to move through the solar system, kind of from the starting at the sun and moving outwards and exploring missions that are happening. Varun, yes, we are going to be talking about SpaceX a little bit. Lorna, if we go until 4 o'clock, I think I'll be wrapped up by 4 o'clock. But you know, I'm really excited about this. So we're just going to go. Luke, you asked, what does Roscosmos stand for? Well, Ros, I think, is for Russian. Cosmos is, it's the Russian word for space. So in America, we call our people astronauts, those that go to space. Astro, space, and naut is like explorer. I think that's what naut stands for. In Russia, they call them cosmonauts because cosmo is the Russian word for space. And out of China, they call them taikonauts, which I think taiko is the Chinese word for space. I'm not positive on that. And I trust that if anyone has the correct answer on that, that you will correct me in the Q&A section. ESA stands for European Space Agency. The extra E right there, that part is the logo, and it stands for ESA. So it's not EESA. Okay, let's get into it. Talk about our first mission, Hinode. This is a Japanese word that means sunrise. This is a Japanese probe, and I hope you can all see the upper right corner. Next to each mission, I'm going to put the logos of the organizations that are responsible for these missions up there. So this is from JAXA. This is from the Japanese. And Hinode launched in 2006. It is still orbiting the sun right now. Other organizations also call the Hinode probe the Solar B probe, or the Solar B spacecraft. And it is studying the sun's corona, not the surface of the sun exactly, but farther out as you go out into space and you can't normally see the corona. There's a big glowing ball of gas that's around the sun that's way hotter than the sun itself, than the surface. The surface of the sun is, I don't know, 5,000 to 6,000 degrees, maybe more. The temperature of the corona is 1,000,000 degrees Celsius. Why is the corona so much more hot than the surface of the sun? Scientists don't really understand that, and they really want to understand it. So they have the Hinode probe and several others causing that. Nope, it has nothing to do with the coronavirus. The sun, the corona of the sun has nothing to do with the coronavirus. It's just a similar, that they use a similar word to describe it. All right, the Parker Solar Probe. I love this guy. This launched in 2018. It's currently orbiting the sun right now. NASA, this is a NASA project here. And this is the first man-made object to touch the sun. I say touch in quotation marks there because it's not touching the surface of the sun, but it is getting much closer to the sun than anything ever has before that's been man-made. And you can see its orbit here. The yellow bit is the Parker Solar Probe orbit. And its first orbit around the sun was, I hope you can see my mouse here, this one on the outside there. Each time it orbits, it gets a little bit closer to the sun, a little bit closer, a little bit closer. And it has a really advanced heat shield to protect it from just burning up when it gets that close to the sun. It can't stay there for long, so it has to make these quick, short passes and then go out and kind of cool off, be like, oh man, get a drink of water, step into the shade for a little bit, and then go back in for another pass to collect more information. All right. Next up, we have Messenger. Messenger is one of our probes to Mercury. We haven't done a ton of missions to Mercury, but we have done some. So NASA, it sent this. It launched in 2004, and it ended in 2015. It took 6 years, 7 years from when it was launched to actually arrive at Mercury. If you launch it wrong, if you send it to Mercury in the wrong way, then it would just crash into Mercury, or it would be going so fast that it couldn't stop at Mercury. It couldn't slow down and actually stay there. So they had to be very careful. They were hoping that it would take like 1,000 photographs of Mercury before the end of its life. It ended up taking 200,000 photographs. It way exceeded what they thought it might do, or what they were hoping that it could do. And you're going to hear that kind of story a lot. We hoped it would last for 30 minutes. It lasted for 200 minutes or something like that. The brightest men and women in humankind work on these missions. So when they get it right, they really get it right usually. At the end of it, it collided with Mercury. They didn't have enough fuel left on the Messenger probe to adjust how it was flying, and it just crashed into the planet. But they knew that was going to happen. That was kind of their point. They were on purpose having it orbit really, really, really close to the planet to get really good photographs. So that's okay. They meant to do that. Venus. So Venus, humanity, has sent at least 43 missions that I was able to count to Venus. There's no current missions there right now. We don't currently have anything on the surface or orbiting Venus that I'm aware of at the moment, but a lot of groups have done research on this. NASA has sent plenty of probes there. JAXA, the Japanese Space Agency, and the European Space Agency have sent missions. The Soviet Union did more work than anyone else on Venus. They sent a lot of probes there. They sent orbiters to orbit the planet and get information from space like that, and also a lot of landers to try to make it down to the surface. Venus is a very difficult, very, very difficult planet to land on because its atmosphere, the air is super thick, it is super dense, and it's super hot, hundreds of degrees Celsius. If you took a large pizza and you put it on the surface of Venus, it would be fully cooked in 9 minutes and it would be burnt in 10. So I hope you like hot pizza, and I hope that you eat quick. And I hope you like a lot of pizza because you're going to burn a lot of them on Venus. So now I know I said that this is about current missions in space, but every once in a while, I'm going to go back in time and tell you about what I think a really, really important historic space mission is. Venera 13 from the Soviet Union. This thing landed in 1982. It lasted 127 minutes on the surface of Venus. That picture right there, that's a real picture from the Venera lander. And they had other landers that lasted for a few minutes and stuff like that. One of them lasted an hour. Venera 13 lasted over 2 hours on a planet that is so hot that you would burn your pizza in 10 minutes. That's incredible. Really, I'm really impressed with what they were able to do. Okay, missions to the moon. Luna is a proper name for the moon. Lots of planets have moons. We have one. Jupiter has 60. Pluto even has 2 or 3 moons. So rather than just call it the moon, we also call it Luna. Nothing else is called Luna, just our moon. We've sent, a lot of people have sent missions to the moon. NASA, definitely. And probably the most historic mission in history is Apollo 11, that first mission landing men on the moon. And that was NASA. The Russians, the Soviet program sent a lot of stuff to the moon, and Roscosmos, the current Russian program, has also sent stuff. Europe, Japan, China, India, individual countries as well. Israel just recently launched a probe to the moon. It did not survive the journey, but they tried, and that's super exciting. One of the most, Ethan's jumping in, says Jupiter has 67 moons. Yep, there you go. For now, who knows? They might discover another one next week and it'll be 68. All right. I am super impressed with the Chinese Space Agency because in 1973 was the last time that humanity had a rover on the moon, roving around, driving around, doing science. Finally, in 2013, China put another rover on the moon for the first time since 1973. And it was expected to last up to 3 months, but it instead went 31 months. It was very impressive. And it was there, and they lost contact with it, and it lost power, and then it got power back, and then they lost contact, and it got back in touch with them. It was a very dramatic mission there. And that was called the U2, and that means Jade Rabbit, which is a really pretty name. So China was like, you know what? That was super successful. Let's launch U2-2. So Jade Rabbit 2, that is currently on the moon. I don't know if U2-2 rover is still operational, but I know that Chang'e 4, which is the name of this lander right here, I'm probably saying these names incorrectly. So if my pronunciation is off, I apologize. This is the Chang'e 4, and it landed, and the U2-2 rover came out of it and drove around. This was the first mission from humanity to ever land on the far side of the moon, the side of the moon that does not face the Earth. That was very challenging, and they pulled it off. It was very impressive. Also, the Chang'e 4 had a bunch of seeds on it. So after it landed, it turned on this heater. It had these seeds in Earth that it brought. It brought dirt in a sealed container. And it turned on a heater, and it warmed up the Earth to about 24 degrees Celsius, Fahrenheit. It warmed it up, made it nice and warm, and it watered the seeds, and it was able to sprout several different types of seeds, and they survived for 9 days. After 9 days, the heater broke, and it wasn't able to keep the dirt warm, and the plants died. But that's the first time that anything had grown, any plants had been grown on the moon by us. Super exciting. I really like what China's doing there. All right. Ethan said it's 79 moons. He double checked. All right. Thank you very much. I'm glad that I have you here with me. Around Earth, the best mission we have going right now, the International Space Station. This thing is the size of a football field, and it was a joint project. NASA worked on it, Roscosmos, the Russians worked on it, Europe and Japan all worked together to build this thing over the course of many years. It cost $150 billion to build. It costs $3 billion per year just to maintain it, just so it doesn't fall apart. But it's totally worth it. I think it's a really, really good use of collective international money. Because October 30th, 2000, that was the last calendar day that there was not a human in space. I hope that that continues to be true for the rest of our history. I hope there is not a single day from here on out that there is not a human in space doing research, doing science, doing exploration. I love that kind of progress. Over 15 different nations have visited the International Space Station. Citizens of over 15 different nations. It's a really impressive collective effort by all of humanity. Varun asks, is there internet in space? Yes. So they have very specific, some of these panels and dishes and stuff that are on the International Space Station are specifically intended to keep the space station in touch with Earth. But every mission that we send to the Sun or Mercury or Venus or further out, which we'll talk about soon, it needs to have a way to communicate back to Earth. Some of those are going to have big dishes on the spacecraft itself in order to send the signal back to Earth. Others, it might not work very well to do that. So around Mars, for example, there's a spacecraft orbiting Mars, just circling Mars in space. And its job is to receive signals from the rovers and the machines that we have on the surface of Mars. So those, rovers on the surface of Mars send a signal to that Mars orbiter, and that orbiter sends that signal to Earth. Earth sends a signal to the orbiter sends the signal to the rovers on the surface of Mars, and we've basically got internet. Okay. All right, a few questions here. Riley asked, what are we talking about? Riley, I'm so glad you can join us. We're talking about missions in space. Stick with me. I'm not going to rewind because I've already talked about quite a bit. I've got way more to talk about. I'm just going to keep going. So I'm glad you're here, and I hope you're excited to learn about what's going on. What materials are in the ISS? Bailey asked. Bailey, it's made of many different things, a lot of metal. It's probably a really complicated composition. It's probably built out of several different things, all with their own purposes and stuff like that. That might be a whole webinar that we could do just by itself. Okay. All right, how long has the ISS been in space? They finished constructing the ISS in about 2000. In the year 2000, October 31st, another mission launched up with 3 astronauts, and they've been taking turns in the International Space Station ever since. I don't think it's been less than 3 people in the International Space Station at any moment of time since then. Teams will come up, and the team that was there will go away, and then a new team will come up and replace the team that came second, and they take turns. Okay. We're going to talk about Mars. Mars, except for the Earth, I think Mars has had more missions from humanity than any other object in our solar system. We've sent more than 50 missions there. More than half of those missions have failed because space is difficult. It's tough. There's a lot of random stuff going on out there. It's not made for living beings to just kind of run around and explore. It is cold, it's dark, or it's hot, or it's really cold, or one or the other. It's kind of not really in the middle. There's a lot of dangerous stuff flying around out there. And everything is really far away in space. If I tried to send a spacecraft from here to Mars, it would be like me trying, I'm just going to make up an example that's probably incorrect, but it gives you the right idea. It would be like me trying to throw a paper airplane from Seattle and land it on a rooftop in Portland. Just and hope that it makes it. It's that difficult. That's the kind of sizes and distances that we're talking about. Okay. Lorna asked, how many people are in the ISS right now? It was 6 or 5 or 6 until a week or 2 ago. Some astronauts came back. There's 3 in the space station right now, and there's 2 launching back up there in a few weeks. We're going to talk about that soon. Okay, one of the reasons that one of these missions to Mars failed, remember I said at the beginning, math is super important, and you need to make sure all your basic math is totally right. Otherwise, the more difficult math goes wrong. One of the more famous failures of a mission to Mars, I forget the name of the exact mission. It was in the 90s, I think. And the idea was to take a spacecraft and to, I think it was supposed to orbit the planet. It was supposed to go in and just kind of skim the surface a little bit to slow it down. And it was supposed to go into a nice orbit. It was either supposed to orbit or it was supposed to land, one or the other. Well, it was a group project between the United States and Europe. The United States uses the imperial system. We use feet and inches and yards, and Europe uses the metric system, centimeters, meters, kilometers instead of miles. So as these 2 organizations were talking to each other, America is talking in miles and Europe is talking in kilometers. and someone forgot to do a conversion at one point. Like, oh, how many kilometers is the 1,000 miles or something? So they got the math wrong. And instead of this spacecraft going into a nice, easy orbit around Mars, it just slammed into the planet. It just crashed. Oops. I think that NASA uses the metric system now for all their really important measurements and calculations and working with other agencies. I think they use kilometers instead of miles, meters instead of yards, stuff like that, in order to avoid that kind of confusion. I'm not 100% sure on that. That's the story I was told, but it makes sense. And even if it's not true, math is important. Okay, we've got some rovers on Mars right now, and we've had some in the past. There's been a lot of failed missions to Mars. As I said, over half of them have failed, but the recent Mars rovers that NASA has sent have been wildly successful. In 1997, I was still in middle school when this was launched, Sojourner. And this little robot here, the size of maybe a dog, kind of medium to a large sized dog, went, and Sojourner was supposed to last, I forget how long, but Sojourner was really, really successful. Following up a few years later, two rovers, Spirit and Opportunity, both larger than Sojourner. They were the exact same design. There were just two of them. They went off in different directions. They were both designed, the scientists were hoping that they would last for maybe 90 days, 3 months. If they could get 3 months out of these, then it would be a total success. It would be worth every penny and every minute that they spent on it. Well, neither of them lasted for 90 days. Spirit lasted for, I think, 8 years, and Opportunity lasted 12 years, I think. Not bad for two spacecraft that were supposed to last 3 months. Curiosity came next, and this, it's hard to tell the size of stuff from this picture, but imagine it an SUV, you know, a nice big car. That's about the size and weight of the Curiosity rover. We landed an SUV on Mars. That's amazing. Curiosity, it was launched in 2011. It landed on August 6th, 2012. And they were hoping that this guy would last for 2 years. It's been more than 7 years, and it's still going strong. There's no indication right now that Curiosity is going to die on us anytime soon. All right. Good. Shannon says, yay, all we need now is roads. You know, these rovers are making their own roads. It's pretty incredible. That's a gorgeous, yeah, that right there, that's a real picture. That's Curiosity taking a selfie as it got to the top of this hill that it was climbing. That's a real picture. Now, the Curiosity rover will not last forever. It will eventually run out of battery. It'll run out of power. But until then, it's going to keep going. You can see on the wheels, if you can see where my mouse is circling right there, it's starting to take some damage. You can see holes in the wheels starting to form there. That started happening a few years into its mission. And the next rover, which I'm going to talk about in a second, they have changed the wheel design so that they don't have this problem happen again. Okay. One nice thing about the Curiosity rover is it has a great Twitter feed. A team of people at NASA send out tweets as the rover itself. And you can see, so like here it is talking with Britney Spears back in 2012. Britney Spears asked, so Mars Curiosity, how does Mars look the same as it did in 2000? And she linked the video. And Curiosity rover said, hey, Brit. It's on first name basis with Britney Spears, of course. Mars is still looking good. Maybe someday an astronaut will bring me a gift too. Drill bits crossed, like fingers crossed, but it doesn't have fingers, it has drill bits. That's funny. This is much more recently. This is just like a month ago on March 9th. It said, what to do after climbing a pile of rocks on any planet? Look at said rocks, gaze into the distance, take pictures of everything, and shoot lasers. optional, but in my honest opinion, both fun and good for remote science. Yeah, Curiosity, one of these bits on here is a laser. It shoots, we dropped an SUV on Mars that shoots rocks with lasers because we're humans. We're going to do it. What it does, though, is it's not just some random laser. We're not just shooting it for fun. We take the laser, it shoots the rock, and the laser evaporates part of the rock. It just burns right through this little tiny part of it. And then there's all these sensors that are looking at the smoke and the dust that come off of that rock. And it can, the instruments on there can use that to find out exactly what was that rock made of. And scientists who study rocks can learn a lot about it just from zapping it with a laser. They can learn about its history. How old was this rock? Was this rock ever in water? I don't even know all the questions that they're answering with this stuff. It's really, really amazing. Okay. Bailey asks, how long did it take to build Curiosity? Several years. I'm going to guess that from like the first idea of someone saying, hey, let's build another rover and send it to Mars, to them landing it on Mars, I think it was like an 8 to 10 year process. It takes a lot of time, a lot of work, a lot of people, and a lot of money. I mean, that's a $1.2 billion robot right there, and worth every single penny. Because you want to take the time to do it right. You don't want to get it wrong. It's too important. So, all right. Lorna says, instruments, huh? Where's the piano? Lorna, you're too smart. Instruments can not only mean musical instruments, but also science instruments. Like the laser is called an instrument, different tools that they use to do different things. Riley asks, is there water on Mars? Yes. Yes, there is. They know this for certain now, thanks to Curiosity and Spirit and Opportunity and these other robots and spacecraft that have been doing research there. They have not found liquid water. Doesn't seem to be the right atmosphere and temperature for that. Although it does get kind of warm on Mars. It gets up to 70 degrees in the middle of summer sometimes. But the atmosphere is super thin. So they've not found liquid water. They think there might be liquid water under the surface in oceans underground, perhaps. They have found that there is water ice below the surface, just below the surface. You scrape the dust, and in some places there's water ice immediately below the surface. All right, can humans breathe on Mars as well as they can on Earth? Nope. Don't do it. Don't try it. You're gonna die quick. It's not good. Even though there is an atmosphere on Mars, it's 1/100th the atmosphere that we have on Earth. It would take 100 Martian atmospheres to have just the same kind of air pressure that we have here on Earth. And even then, it's not made of the right chemicals. It's not made of the right stuff. There's not enough oxygen there, and you would not be able to breathe. All right, so what's coming up after Curiosity? Perseverance. This launches in about 5 weeks, I think. No, a little bit longer. July 17th of this year, this Mars Perseverance rover is going to launch from Florida. It's going to land on Mars in February of 2021. And it's about the same size as Curiosity. And it's going to land in a very similar way. And you'll see the wheels have a slightly different design. They're more, they're less likely to break than Curiosity's were. And its job is it's going to look for signs of past life on Mars. They think that they might find fossilized bacteria, really simple single cell life from the past, fossils of that in the rock somewhere. They're looking for that. It's going to collect rock and soil samples and prepare for future human exploration. One of the reasons it's collecting these rock samples is in 2 years or 4 years or 6 years, NASA's planning another mission to send a thing to Mars and to collect those rock samples, some of those rock and soil samples that Perseverance gathers, and bring them back to Earth. Bring Martian rocks to Earth so that scientists here can study them directly. Okay, it's also bringing a helicopter because it's awesome. So we are landing an SUV on Mars to shoot rocks with lasers and fly helicopters. This thing is about 4 pounds, and those blades, those propeller blades you see there, are about 4 feet wide. It needs a really big helicopter propeller in order to actually fly in that very, very thin Martian atmosphere that I was talking about. So about 2 months after Perseverance lands, it'll look around, it'll find a good place to put the helicopter, a nice flat. I mean, you can see here, it's flat. There's no extra rocks around there. It'll drop it off, it'll drive away, and they'll fly that helicopter on and off for about 30 days doing a bunch of tests. And it's just a test helicopter to just kind of figure out, does this work? Does this work the way that we want to? Mackenzie, you're asking why a helicopter? 2 reasons. 1, it's really cool. And 2, it's really useful. It's very difficult to operate a rover on another planet. You need to be extremely careful. These things do not move more than probably a foot any day. They have to move very slowly and very carefully in order to make sure it doesn't drive off a cliff or get stuck on a rock or hurt itself or something like that. A helicopter would allow you to do a lot more exploring and a lot more research in the same amount of time. You don't need to worry about if you're driving forward, hitting a rock, or maybe one of your wheels gets stuck in a bit of loose sand that you weren't expecting. This thing you can tell it to fly up and to fly in a 10-meter circle around and take pictures and like detailed 3D scans of the ground and come back and land. You can do way more research with that than you can stuck on the ground. And from that, you can then tell your rover, hey, I saw a really cool rock over there. Let's go shoot it with a laser. Okay. So Mars Insight, this thing landed in 2018. And ever since then, it's been taking, this one's not a rover. It's not moving around. It landed in one spot and it stayed there. But it's taking weather measurements every day, temperature, wind, air pressure. And we're learning a lot more about the Martian atmosphere and Martian weather. And this bit sticking off to the side here, that detects Marsquakes. Did you know that there's earthquakes on Mars? Well, there's not. There's Marsquakes. They call them Marsquakes. On Earth, we call them earthquakes. On the moon, we call them moonquakes. On Mars, we call them Marsquakes. They have detected over 450 Marsquakes since they set that thing down about 2 years ago. And scientists can learn a lot from earthquakes. It can kind of give them a picture of what's happening inside the planet. So we're learning a lot. It's been a very, very useful mission. Okay. Mackenzie, you were asking, what does it do? I think you're talking about the helicopter. That helicopter, that Mars helicopter, it's actually not going to do a whole lot of science all by itself. It's not going to go find signs of past life on Mars. What it is going to do is they have scientists and engineers, they have these ideas of what might work. And they put a bunch of those ideas into this helicopter. And this is really just testing, do our ideas for a helicopter work? Because if not, and it breaks, oops. But if it does work, the next helicopter that we send can have more instruments on it, and we can invest in putting more expensive stuff without being worried about losing it. Okay. Oh man. Okay. This is the Rosetta spacecraft and the Philae lander. Philae is this little bit that dropped down from it. It was riding on the Rosetta spacecraft, and it brought it to a comet. Let's see. Okay, so this is from the European Space Agency. These guys have really done some incredible work. They saw that this comet was going to be coming close enough that we could send a spacecraft to it. This is great. We want to know more about comets. When the solar system was being formed about 4.5 billion years ago. We want to know more about exactly what happened and how it happened. And comets are kind of the leftover junk and trash that didn't get scooped up by the sun or by planets or moons. And these comets kind of hang out usually in the far bits of the solar system. It's a time capsule. We can see, I mean, like this comet is basically unchanged in the last 4.5 billion years. And if we can understand it better, we can understand more about our solar system, how it formed. So it went to this comet, 67P. Kind of looks like a rubber duck, doesn't it? It's about 4 kilometers wide. And what they think probably happened here is it kind of looks like 2 comets, right? Like 2 chunks. Like here's one chunk and here's another chunk. And what they think might have happened is that, I mean, both of those chunks have gravity to them, a very, very weak gravity. But let's say that these were 2 comets flying along kind of close together. And over billions and billions of years, they slowly got closer and closer because of their very weak gravity. And then just kind of boop, stuck together. And then over time, enough like dust and ice and stuff just kind of fell and filled in the cracks there at the neck that you can see. This is a real picture taken by the Rosetta spacecraft as it approached Comet 67P. This is really amazing. This is the best picture of a comet we'd ever had to that point. And this is a video. This is a video taken by Philae as it was descending to the surface of Comet 67P. And they tried to land it very, very carefully, but they were still a little bit too rough. And it came down, and again, this gravity is super weak. If I took, this mouse and I dropped it, it would probably take many minutes for it to hit the table. That's how weak that gravity is. So it actually bounced quite a bit when it first dropped to the comet, and it bounced and it kind of went sideways a little bit. And I think that's where this sequence of photos was taken. What does that look like to you guys? Does that look like snowfall? Here, let me run into the Q&A section really quick. Anyway, it looks like snowfall to me. An asteroid could be described as a giant, dirty snowball in space. And yeah, Shanna says it's snowing. That's basically what's happening. So as this giant, dirty snowball approaches the sun, it starts to warm up and some of that stuff starts to boil off and boil away. But then again, there's a very weak gravity. So some of that stuff then slowly comes back to the comet and settles gently on the surface of the comet as basically snow. This is comet snow. And you can see that it's pretty smooth down there. That looks to me like when I would wake up after a night of snow in Michigan where I grew up, and you look into the backyard and there's this gentle, undisturbed snow. That's kind of what that looks like to me. Lorna says this is a very annoying video. It could be that way, but okay, good. I'm going to go to the next thing. All right, I just love that video. Okay, so we've sent a probe. We've sent a spacecraft to a comet. We also wanted to send one to an asteroid. So an asteroid is made of rock. Comet is made of more water and ice. So NASA was like, let's send something to an asteroid and let's find a really interesting part of that asteroid and really interesting rock and bring it back to Earth so that we can study it at Earth. So it launched in 2016. This is the OSIRIS-REx mission. They have really cool names. Launched in 2016, it arrived at the asteroid called Bennu in 2018, and this thing lives out kind of past Mars in the asteroid belt out there. And so it's going to orbit for a long time. It's going to do a bunch of science and observations and measurements and science stuff. And it's going to find a really interesting rock, and it's going to send it back to the Earth in 2023. And then there's going to be a bunch of really happy scientists. Okay, so as I predicted, it's 3:15. I am not done with this slideshow. I'm going to keep going. Stick with me. I'm going to speed up a little bit. Jupiter, we've sent a lot of missions here. Pioneer 10 and 11 in 1972 and 1973 gave us, I mean, that picture of Jupiter there, we couldn't take that from Earth. This picture is either from one of the Pioneer missions that first got really close up, or it's from one of the Voyager missions, Voyager 1 and Voyager 2. We're going to come back to Voyager 1 and Voyager 2 in a few minutes. That's why there's no other text here. Galileo launched in 1989, and it crashed into Jupiter on purpose in 2003. And scientists did that because they think that there might be life. There's a chance that there's life on some of Jupiter's moons. So they don't want to crash a spacecraft into one of the moons by accident and contaminate it and get like human stuff on the moon. They just want the possibility of that moon life to remain undisturbed. So they crashed into Jupiter instead to keep the moons safe. What Galileo was able to do, it just happened to be in the right position in 1994. There was a comet, which we just talked about, comets. Well, one of those comets called Shoemaker-Levy 9, it ran into Jupiter. It collided with Jupiter in 1994. And Galileo happened to be in just the right spot to catch this happening. And we won the cosmic lottery with this. We were able to see and learn things about Jupiter that we would have had no chance to learn or to study at that time. Really amazing luck there. Thank you, Galileo. All right, Juno launched in 2011. It arrived at Jupiter in 2016, and it's still there. It's still orbiting. And one of the main things that they wanted the Juno mission to do was to look through that super thick top layer of clouds around Jupiter and see what's happening inside. We got a tiny peek from Galileo when that comet hit the planet and kind of made this explosion that moved the clouds away a little bit. We were able to see in just a little bit. So Juno is named after the Roman goddess Juno. So Jupiter in Roman mythology was the king of the gods, and he drew clouds around himself to hide his mischief. And his wife, who was named Juno, she was able to see through those clouds and to see what was actually going on, what he was doing. So if you've ever like tried to hide from your parents, you're like sneaking that candy bar and you've got your sheets up and you're eating the candy bar and your parents come in, they see past the blanket. That's kind of what's going on here. So that's why they named it Juno, because it can see through the clouds of Jupiter. Okay, Saturn, the most gorgeousest planet other than Earth, because it's got pretty rings. So this is a two-part mission. NASA built the Cassini spacecraft, which is this guy here, and the European Space Agency built Huygens. That's how you pronounce that. Launched in 1997. And Cassini was orbiting Saturn and its moons and collecting incredible amounts of information. Meanwhile, on December 25th of 2004, Cassini delivered its Christmas present to Saturn's moon of Titan. And that's the Huygens probe. Titan is huge. It's bigger than Mercury. It's bigger than the planet of Mercury. It has a very thick atmosphere. It's 4 times thicker, 4 times more dense than Earth's atmosphere. And we wanted to see what was going on. We couldn't see past that cloud layer on the top of Titan. So on January 14th, a few weeks after being detached from the Cassini spacecraft, the Huygens probe entered Titan's atmosphere. And these on the right are real pictures that Huygens took on its descent through the cloud layer, and then it can see these mountains and valleys on Titan itself. Engineers hoped that it would last for 3 hours. It had enough battery life for maybe that much. Not only did it survive 2.5 hours parachuting down through the atmosphere, but then it survived on the surface for 72 minutes, transmitting incredible amounts of information. These are real pictures of an alien moon. How cool is that? Cassini, at the end of its life in 2017, for the same reason that we crashed Galileo into Jupiter, we don't want to contaminate Saturn's moons. Let me go back a slide here. Huygens was different. Yes, we did land Huygens on Titan. They were very careful. They cleaned Huygens as thoroughly as they could to make sure that no human stuff got to Titan. They think there might be life there. There's other moons of Saturn that they think might have life. So in order to keep Cassini from accidentally hitting one of the moons, as it was running out of fuel, they used the last bit of that fuel to crash Cassini into Saturn itself. And that's an artist's idea of what that might have looked like. Super cool. New Horizons. This guy launched in 2006, and it is still flying through space right now. It was the first spacecraft to get really up close to Pluto. On the left here, this was the best picture we had ever taken of Pluto. This is from the Hubble telescope. This amazing, like one of the best telescopes ever created in the history of humanity. And that's all Hubble could see of Pluto. So we sent New Horizons, this gorgeous spacecraft. And it went really close to Pluto, and it took these amazing pictures. And you can see here's like a heart-shaped kind of formation there of what they think is snow, carbon dioxide snow or something like that. And that shape right there is about the size of Texas. It zoomed past Pluto, and it is now heading to the outer solar system. There's a number of small little asteroids and stuff out there that it's going to fly past and look at. And they're just going to keep that thing going for as long as they can. It's too far gone. It's going too fast to turn it around. So it's just going to keep going until it leaves the solar system. All right. So Voyager 1 and 2. I promised we were going to come back to Voyager 1 and 2. Voyager 1, if you hear shouting in the background, don't worry about it. It's just students in the hallway. Usually I'm done broadcasting by this time, so they know that they don't need to be quiet. Well, I decided to go along today. So here's a video. There's no sound to this. I'm going to read what's going on, and you can just watch the paths. I know it's going to be a little choppy on your end. So Voyager 2 launched in August 1977. Voyager 1 launched shortly after that. They're flying along through the solar system, and they're going out, and they're going to fly by Jupiter. Here they are, and let's see, so before the end of the year 1977, they have passed the asteroid belt, they've passed Mars, they're approaching Jupiter, and look at what happens when they pass by Jupiter. They're going to get super, 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 super close to Jupiter. And so March 1979, Voyager 1 passes by Jupiter, and it goes, poof, and it goes firing off. And then Voyager 2 does the same thing a couple months later. And they get sped up by Jupiter. Voyager 1 passes by Saturn, whoom, picks up a bunch of speed, and it goes up and out of the solar system. Voyager 2 passes by Saturn, picks up even more speed. It heads for Uranus. It's going to do the same thing at Uranus, go zipping by Uranus, pick up even more speed. It's going to pass by Neptune, whoom, and then it goes down and out of the solar system. I hope you guys could see that well. So here's what's going on right now. They have gone so far, Voyager 1 going up, Voyager 2 going down. They have left our solar system. They have left the part where our sun is providing the most influence and particles and stuff, and they are now out in a part of space where they're getting more signals and heat and stuff from other stars than they're getting from our own star. We have two objects that have left the solar system. And I forget if Voyager 2 is still operational. They might have lost contact with it. Voyager 1 is still going, and we still have contact with it, and might even for a few more years. It's over 40 years old, and it's still going. Good job, humans. All right, we actually are approaching the end of this slideshow today. Finally, we're super late, but I have a little bit more to show you. We're going to keep going. Cannon asks, how do satellites send pictures all the way to Earth? That's a big answer that I don't have time for right now. Basically, here, let me go back really quick. See that big satellite dish right there? They use that to send a super strong signal back to Earth that we can barely hear. So they send it super strong, it gets weak on the way, but we have the right equipment to listen. Okay, what missions are coming next? Okay, Dragon Crew in a few weeks, a month, May 27th. This spacecraft is going to launch from Cape Canaveral in Florida. It's going to have 2 astronauts on board. For the first time since 2011, astronauts are going to launch from American soil to space. And they're going to be on that spacecraft right there, the Dragon Crew spacecraft. Super exciting. It's going to have 2 people, but future missions could have up to 7, space of up to 7 people in that spacecraft. It's really great. This is the Gaganyaan spacecraft. That means sky vehicle in Sanskrit. And this is, I talked earlier about India. India is getting into the space game. So this is from India. It's the Gaganyaan capsule. And it's going to be the first manned space flight from India. I'm really happy that they're taking part in this. I think by the year 2030, India is going to be doing a lot more in space than we might expect. Keep an eye on that country. James Webb Space Telescope launches next year. It is going to be more than 100 times more powerful than Hubble. It's going to be able to see 100 times more. And it's going to be able to observe different kinds of things than Hubble is able to see. So I can't even, I could talk about this for a long time. I won't. Tiangong 3. So China has had 2 space stations, Tiangong 1. Tiangong 2, I think I don't know if it's still up there right now, if it's still in operation. Tiangong 3 is going to be their next space station. And so they plan to have this, they're building it right now. They plan to have it fully operational in 2022. China is planning a bunch of stuff for this current decade. They want to put astronauts on the moon, on a permanent lunar base by 2030. They want to send probes to Mars, including some probes that could return parts of Mars to Earth for study. Good job, China. How about other stuff to the moon? SpaceX. This is not a country. This is a private company. They have what's called the Dear Moon project, and their goal is to send 8 astronauts on this spacecraft that does not exist yet, but they're working on making it. 8 astronauts to go orbit the moon and come back in 2024. Why artists? Because artists are the heart of our society. The engineers build stuff, the scientists figure out how things work, the teachers teach us how to do it. Everything, the artists use their imagination to envision what is possible. And that inspires everyone else. So, hugely important. I hope that goes well. Also in 2024, after SpaceX announced the Dear Moon project, NASA and the American government announced the Artemis program. They're like, you know what? We haven't had humans on the moon since the 1970s. That's it. It's time to go back. We're sending humans back to the moon. We're going to call it the Artemis program. And by 2024, we want to have humans on the moon again. They're going to have a space station orbiting the moon. From there, they can make trips down to the moon and back. And then the next step after they have all that going is to make a permanent moon base. That's super exciting. We talked about putting a helicopter on Mars. Well, they're going to do something similar on Titan. So this is Dragonfly. And it's got 8 rotors. And so it's like a quadcopter and an octocopter. It's got 8 of those things. So imagine like a big drone here on Earth. That's basically what that is. Its blades don't need to be as big as the ones on Mars because Mars has a very thin atmosphere. Titan has a very, very thick atmosphere. So it's a lot easier to fly in that atmosphere. It's going to launch in 2026. It's going to land in 2034. It's going to take 8 years to get to Saturn's moon of Titan. And they're hoping that it is able to explore Titan for 32 months. But hey, the Spirit and Opportunity landers were supposed to last 90 days, and they lasted 8 and 12 years. Curiosity was supposed to last 2 years. It's going on 8 years now. So they say 32 months for Dragonfly. I think it could do more. Let's find out. Okay, we finally made it to the end. Thank you so much for everyone who's been able to stick around here. Wow, there's a lot of you still here. Go ahead, throw me some questions if you have them. Even after I turn off the camera and microphone, I'm going to hang around in the Q&A box for a few minutes to try to answer stuff. Shanna, thank you so much for coming. Isis, thank you too. You're welcome. Lorna says NASA needs to put a permanent settlement on the moon. Yep, they're working on it. First, they want to get that space station around the moon as a much easier step. And then they want to get missions down to the moon and back. That'll be very, very important. And then they'll be able to build permanent stuff on there. I really hope that they do. Renbeer asks, is the core of planets and sun hot because of pressure from the outer layers? Like pressure from the outer layers of the solar system pressing in, or pressure from the outer layers of the sun pressing out? Because it's definitely that second part. The pressure, the heat, the energy, the radiation coming from the sun radiating outwards is what warms us and Mercury and Mars and everything. And the farther away from that you go, the colder it gets because the less of that energy is able to reach you. Vanessa says she loves SpaceX. Me too. Love those guys. Great, great work. Good. Milo says, why don't they send up a rocket on the moon to go to Mars? Milo, people are thinking of doing that. And we might see that within the next 100 years or so. It's difficult. It's very easy to launch stuff from the moon. There's no atmosphere. The gravity is only 1/6 that of Earth's gravity. It's much, much easier to launch from the moon. But it's more difficult to build on the moon because you need to make all the air that you breathe, and just living on the moon is very hard. So we need to figure that out first before we figure out how to build spacecraft and stuff like that on the moon. It's possible, but right now it's more science fiction than science, but it's possible. Mackenzie asks, have humans been on Mars? Nope, not yet. We have our toys there. You know, we have cars and helicopters that we're sending there. So we have our broken toys littered all over the place, but no humans yet. There's current plans. One of the big points of the Artemis mission that America has, everything that they do to build bases on the moon, to survive on the moon, all of that can be applied towards living on Mars. So if we have an idea, we test it on the moon. If it works there, it'll work on Mars. So, and it's much easier to do it on the moon. It's much, much closer. It's 236,000 miles away, and Mars can be up to like 40 million miles away. So it's a lot closer. If anything goes wrong, it's easier to come home. Are there plans for a permanent settlement on Luna? Ron Beer, thank you for the question. Been kind of talking about that here. All right, Fallon says, why not send a fully made rocket with other people up to the moon? From there, they could take off and go to other places, right? So that is an idea that's also happened. So they're thinking of an idea, a concept. There's no hard plans for it yet. But they've definitely thought that it would be nice to have a base on the moon. And from there, you can launch stuff from Earth and launch it in pieces and assemble it, just put it together on the moon, or maybe launch from the Earth to the moon, refuel on the moon and launch from the moon to Mars, or Jupiter or wherever? That's the kind of question that gets you a job at NASA. Keep asking that question and keep asking, figuring out for yourself why it would or wouldn't work and how to make it work. Lorna asks, has anyone ever left the Milky Way? Nope, way too far. We're, as I talked about with Voyager 1 and 2, we just got human probes out of our solar system just a few years ago, like 2 years ago, something like that. Those are some of the fastest objects ever made by man. Getting out of our galaxy at that rate would take millions of years. So we don't have the technology for that yet. Mackenzie asks, what's the temperature on the moon? Depends on where you're standing. If you're in the sunshine, a few hundred degrees, boiling hot. And if you're in the shade, even if you're just standing like on the edge of a crater or something, and right here is sunshine and right here is shade, here it's 200 degrees and here it's negative 200 degrees or something like that. Huge difference. All right. NASA needs to suggest an international moon station. Yep. That's one of the things, this part where I'm circling right here, this is going to be called the Lunar Gateway. And that's going to be the name of the International Moon Space Station. Yeah. Okay, I am going to sign off here. Thank you so much for joining me. First webinar tomorrow morning, 9 a.m. Diego and I are back. We're talking about different space activities. This thing that we're going to do, it's great for younger kids. If you're like 5 to 10 years old, there's activities for you to do there. If you're older than 10, there's still tune in, still join us. And there's a lot that you can learn about how to build space helmets and space suits. And we're going to be talking about what you might need to build for a base on the moon or on Mars. All right. Yep, that's the end of my slideshow. Okay, bye everyone.